Hello and welcome to NARC Live on Wednesday the 10th of September 2025. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G7URP. Lovely to see you all. On tonight's show, Joel W5ZN joins us live to compare vertical arrays for low band receiving. We take a look back at club events last weekend and we find out what on earth this is or what it's for. And I can reveal that this has got most of you Fox this week. So if you are watching this now and you haven't written to us yet and you know what this is or what it's for, you've got just time to put that onto Facebook or BATC and we'll read it we read the other answers. Only had 3 entries I think so far. Firstly, you will have seen a couple of weeks ago, both on this programme and also on the newsletter, that we announced we were organising a sale for Paul Courtwright G3 SEM's remaining equipment. And that was last Saturday week. Well, if you were at our annual general meeting in April, you'll know that we awarded Paul posthumously a Lifetime Achievement Award, particularly for his work with the voluntary interceptors, or secret listeners as they were often called. But we were waiting for an opportune time to present that award to his wife Rita. Well, that seemed like a reasonable occasion, and the president of the club, Malcolm G3PDH, and I, after the sale, towards the end of the day, we were able to present this award to Rita, and there we are. You can see that we presented a certificate and also a lovely vase which is engraved as well as a Lifetime Achievement Award. And Rita was really delighted and proud and pleased and very surprised with this award. First time, I believe, certainly in my tenure, since I've been a member of the club, that we've ever awarded something like this. But as I said, particularly apart from the things that Paul did for the club, he really did an awful lot to get the voluntary interceptors from the Second World War officially recognised by the secret services, which he did manage to do before his passing earlier this year. Now, I'm not quite sure how to tell you about this, but I'll just tell you directly because that's how it should be. I'm sure many of you will have seen this radio before. It's actually called an ICOM IC705. That's it. It has a battery that you can fit in the back. And it's one of a fairly new generation of ICOM radios, which is portable. That's the key bit. It's only got 5 watts or 10 watts if you power it on more voltage. And it works on just about all the bands, including VHF and UHF, and right up with all of the HF bands. Well, the reason for showing you this now at this point in the programme is that Paul had one of these, which he took with him on a few of his little trips, including, we believe, Rita, to her, many of the radios look the same, but we believe that he took this on at least one cruise as well, and he had lots of other bits and pieces as well, including this ATU unit, which you might know about, which will literally tune anything on a long wire. Why am I talking about this now? Well, this was Paul's, and Rita has to, when she found out what it did, she wanted to donate it to our club. She said that Paul and her had often talked about making a donation of some kind to Norfolk Amateur Radio Club, and when we were sorting out the remainder of Paul's equipment, this was there, and overnight she decided that that's what she wanted to do. There was no changing her mind. I felt a little bit embarrassed almost about it because we were just sorting it out to sell, but that's why it wasn't in the sale, because Rita has decided that this would be a very apt thing to give to our club, which means to you, our members. That this would make a lovely radio that we could put out on loan. As you know, we've got rid of some of our older equipment recently, and it's no secret to say that we were thinking about some more modern equipment, and this would certainly fit the bill. And we think that this is something that lots of members actually will find useful. The sort of thing we'll lend out for a couple of weeks, maybe, if you're going away on a holiday, or maybe you're going on an expedition. Not everybody would have the sort of money to shell out for something like this for just occasional use. So it does seem a very appropriate thing. Now we're going to check it all over. I don't expect there's been for a moment there's going to be any problems with it, but one of our members, Kevin M0UJD, has got one of these, and he's going to check it all over for us. We're also going to label it, engrave it, and also we're going to put a nice plate on the top to remind members now and in future generations of that this was given to us by Paul G3SEM and his wife Rita. So we thought we'd reveal that news to you tonight. We're very, very chuffed about it, and it'll be available on loan certainly, I would think, within a month or so, once we've just checked it over and done all the labelling and everything else. But it's a lovely, lovely thing to have, and this will be available for members to borrow. So thank you very much to Paul and Rita for that wonderful gift, and it will mean that, of course, your memory will live on in many special ways as members use that radio. Now, last weekend we had two events which we've been waiting for. Friday the 5th of September was our long-awaited coach trip to the National Hamfest. In the end, we had 30 people. I was scraping around trying to get more than 17, I remember, by my sort of initial deadline before we had to confirm the coach. But you didn't, although you did worry me a little bit, but we certainly came through in the end. And to have 30 people there meant that we covered our costs, and we were able to go there on Friday. This is a picture of everybody on the bus, so you can see there's 30 people there on a big 49-seater coach, so lots of space. And you'll notice that everybody, I don't know what Alec was doing there, holding his hands up, but anyway, you'll notice that everybody looks very, very happy. And if you're wondering why everybody looked happy, you just have to see what was parked next to the bus to know that we didn't look anything else. This was at a truck stop on the way at Gedney, a famous truck stop between Norfolk and Newark, but there we are. Thanks very much to Smith's Coaches for excellent service yet again, and we got there and back, I think, in the smoothest journeys we've ever had. But thanks to all of you who came on that trip and supported it, because as they say, without you we just couldn't have run it. It's a very expensive business to hire a coach for a day now, and but we're pleased that we were able to do it. I think probably the only coach certainly that I saw there from a club, so really, really good. Now, the other thing that happened just 2 days later was on Sunday we had our Radio by the Seaside event. This, of course, was postponed from July when we were meant to have it, and then there was awful weather forecast. Well, when I set this new date, it was for just after the schools go back, so that the owners of the car park there would give us our own area. But I didn't really know what the weather was going to be like, because it's been quite changeable. But luckily on Sunday we had lovely warm weather, albeit windy, and these are just some of the pictures from Sunday. There we go, some nice memories there.
A little bit hillbilly-ish.
It was a bit hillbilly-ish. Unfortunately, our guest in the US, who's waiting to come on here, he couldn't hear the music that went with it, but it was appropriate, I think, it'd be fair to say. And that wind, I mean, you saw the kite there that Bill was trying to fly, but it took almost two of them to bring it down. It was really...
a bit windy, wasn't it?
It was. I don't think it would have lifted Mark off, but almost. That really was good fun. Thank you so much for all of you for supporting the event for the second day. It's always a difficult one with weather, because I know it makes a huge difference to the event. It was really, really warm though, but very, very windy as well. Anyway, we'll do another one of those, of course, next year, I think. Now, just one other bit of club news, really not our club, I suppose, but you may have been waiting for the Caister Lifeboat Station Radio Rally, which was due to be this Sunday, the 14th of September. Well, it's been cancelled. I don't know why it was cancelled, but it has been cancelled. So just in case you had been planning on going and hadn't seen that message, it's been cancelled by the organisers. By the way, I should just tell you the pictures from the event. Thanks very much to Mark G0LGJ for some of the pictures, and some of them came from me as well. And thanks for Tammy putting it together as well. Now on to members news, and a couple of things this week. Now I'll add a caveat at the end of this, but firstly, this is from Mike M7TTT. He says, I'm happy to share the news that my mentor, aerial rector and the guide of many NARC club beginners, Gordon, is having a whale of the time in Airy or Ireland. He's just sent me these wonderful pictures from a flight he took, looking over, as he said, potential 3-bedroom properties with acres of land for radio masts. What could he mean? A quote apparently was, just took flight over possible future bungalow. Yes, I did say flight, and played aeronautical, because this is him in the plane as EI3VP stroke AM, which is aviation mobile, I guess. Quite a new mode to be able to work.
Well, you can put whatever you want, I think, at the end, can't you now?
Well, that's true. Yes, that's true. Well, anyway, the Gordon then signed to Mike. Mike forwarded this picture and a message to us and said 7-3. But if you were eagle-eyed a few minutes ago, you would have noticed on the video, Gordon was there because he just got back from Ireland. So he's back from his many adventures that he's had over the last 2.5, 3 months, something like that. So it's good to see you, Gordon, at the Radio by the Seaside event as well. And we look forward to hearing about what you're planning to do in Ireland, maybe. You obviously had a really good time there anyway. So thanks for those pictures, both to you and to Mike. And finally, from our Scottish correspondent, Ralph 2M0RHT, he says, this Saturday, the James Clerk Maxwell Radio Society will be on the air at Parton Kirk for Churches and Chapels on the Air at Parton Churchyard, a few miles from Glen Lair, James Clerk Maxwell's home in Dumfries and Galloway, and holds the grave of the famous Scottish professor. Their call signs for this event are GB2JCM for obvious reasons, or MM0PMS, which was less obvious, but he's put that in brackets. That stands for physics, maths and science, of course. So thank you very much, Ralph, for that information. Now over to you, Tammy, for little people.
Yep, little people. Have you ever wondered about all the remotes that you have sitting around the house?
There's a lot.
There's a lot.
We have got a lot.
We have got a lot. Here we go. That's what you need to do with them.
Oh, that's it.
Just make an airplane.
Jet. Absolutely.
You can't actually see the detail, but there is actually like a person with a trolley going
sitting
up
on every
middle.
button.
And there's somebody sitting on every button.
That's a superliner, isn't it, really?
Yeah.
Fantastic. As we always say, miniature-calendar.com, a new picture about these wonderful Japanese people who run this website every day, and Tammy picks one out for us every week. That's lovely. That's obviously what you do with those old remotes. Should we ever go when we get home?
Yeah.
We've got quite a few, haven't we? So what have you been doing? Don't forget to keep in touch with your pictures and your stories. You know, I know the summer might be over. Why are you laughing?
I'm just laughing at a comment that's just come.
What's that?
It's for the what on earth, so you have to wait a second for it.
I'm not reading that. I've just seen what it says. Anyway, if you've got some news for us, then don't, I know the summer's kind of getting over, dare I say that? It's certainly the weather feels that way. But do keep in touch with us. Send us your pictures to this address, radio@dcpmicro.com, and send them to us by 3 o'clock on the day of NARC Live, which is in 2 weeks' time from now. And we'll be sure to read them out. It can be good fun. And it's a great way of connecting people as well in between our meetings. So thank you. So now back to that competition, which, you're a pretty smart lot, I think, actually. And nearly every time we do a competition, and we do sometimes objects which I have no idea what they are, you have no idea what they are, and we think we've got a few entries. We'll only get a few, but this time we really haven't got many. We've got 4, actually. I think one's tongue-in-cheek. Anyway, 2 weeks ago, I asked you, what on earth is this?
It's a thingamajig.
It's a thingamajig, yeah. Well, you get an idea of scale of it because they're bricks. They're normal house bricks. They're not your miniature calendar bricks, are
No,
they?
they're
They're
not.
real things. They're not Lego bricks or anything like that. So what on earth is that and what is it for? Now, before I read this, dare I look at this, Tammy?
There's actually 2 answers on there now. So one of them.
Well, I can see that bottom. I'd rather read that one. I don't know who you are, Audit Man, but thank you for it. Do we have a name for Audit Man? Who is Audit Man?
M7SEY. That's
Brian.
Brian.
Audit Man. Okay, that's your new name. Have you got a cape and everything? Anyway, Brian says, looks like a toilet flusher handle. I get that. Yep, having messed about with our systems.
I was thinking it looked more like what you put down the toilet to unclog it,
Oh,
actually.
dear.
Anyway.
Lowering the tone. Lowering the tone.
Mike GAEY says, I think it's something from the Anne Summers Industrial Selection.
I am glad you read that because I have a feeling if I'd read it, you'd tell me off. Let me see. Anybody else say anything? No, although I will just mention, I think that's Daniel there, says about the last picture that we saw on the miniature calendar. He says, that certainly explains why I never find my remotes where I put them. Exactly. So no other entries. Okay, well, we've got some from you at home. Bob G6PWS says, this item I recognise as a cross-velocity joint putter honour. In the days when you had to replace or renew a drive shaft system cover, you used one of these to assist you to expand and slip over the joint. Not the best to help, but at least it was something. I mean, even after reading it, I'm not sure
Still don't know what it is. Bruce G4KZT, this week's What on Earth is interesting. The square bar at the end reminds me of a door lock spindle. So is this for setting up locks in doors or possibly a removable door handle?
Yep, get that. Martin G6WNN says, I think the current What on Earth is an constant velocity boot installation tool. It is used to stretch the rubber drive shaft cover over constant velocity joints, such as on car wheel drives. You know.
Clear as mud.
And finally...
That's
oh, you haven't got that one. That's right. Sorry, this is one that I saw. This is from our Scottish correspondent again, Ralph 2M0RHT, who says, I think tongue-in-cheek, this week's object looks like a Bakelite handle with a brass extension which would be secured through the hole therein with a screw to control a switch within a piece of electrical apparatus such as a radio or a throw switch in a power unit. If not, then the brick wall may indicate that I have hit a brick wall. I think that may be appropriate. Anyway, Tammy, let's put everybody out of their misery and reveal what on earth this was.
Well, it is the CV tool.
It is the constant velocity boot installation.
I can't really show you what it does.
I know.
I think one of the answers actually was...
I reckon there's only 2 people got that right, really. Bob G6PWS, because I think that's what he meant with this cross-velocity joint putter honour, and Martin G6WNN. So well done. I know some of you put it into the internet and can work that out, but nobody else came up with the right answers for that. So well done, and thanks to Tom M7EOE for sending that to us, because we weren't any the wiser,
No,
were we?
we weren't. Actually, just talking about putting it into the internet, there was a comment on our Facebook page, I don't know if it was last time or the time before, and somebody put the whole picture like this, which has got your email address and everything on, into the Google reverse search, and it told it that it was a competition from the Norfolk Radio Club and that the answers would be revealed on their NARC Live video, and that it wouldn't tell them what the answer to the actual picture was.
Really?
Because it was a competition.
Oh, fantastic. Really? It did
Yeah,
that?
somebody put it
So was
on,
that as AI, kind of reverse AIing and
it's
realising that it shouldn't help?
Yeah, basically.
Oh,
it was
good.
seeing that it was a competition. It wouldn't
good.
give the answer.
Excellent.
I thought that was pretty cool.
Anyway, thank you very much, Tom. You had nearly everybody fooled. The 350 or so people that see that on our newsletter. So thank you very much indeed. Okay, so now it's time. Let's see if you do any better with this, to say, and think about this one carefully. What on earth is this? I know that to many radio people that will be instantly recognisable as something, but what does it do? What's it for? And is it really what you think it is? I better
Don't
not
give
say
any
anyone.
clues.
No, I know. I always get told off. Anyway, this is what you have to do. Let us know what you think that is or what it's for. Just under 2 weeks' time on the afternoon of NARC Live by 3 o'clock, if you can, please, to radio@dcpmicro.com. What you think that is or what it's for, and we'll read it out. I happen to know what this is, I think, so I'm all right on this one. The last one I really was, even I knew, and I was completely fooled. Anyway, before we meet tonight's guest, let's just have a quick look at what's happening at the club this coming week. So on Sunday, as usual, we've got at 7 o'clock, we've got the GB2RS News on GB3NB. And then next Wednesday, a week from tonight, we're meeting at CNS School for a social informal meeting, and of course including our popular show and share table, which never ceases to amaze me, that just about every time everything goes. By the way, if you're not sure what I'm talking about and you're going to that meeting, if you've got anything that you don't need anymore, but you'd like to see recycled, you know, it's one of those things that's too good to throw away. Is that something that your folks said to you? It's always something I said, it's too good to throw away. Take it to that table, and amazingly someone will find a good use for it. So that's what that's all about. And of course, keep us in touch with your stories and your pictures and your news and everything else. And don't forget this card, which we're always happy to send to anybody who you think will be cheered by receiving a card from your club. We'll add your name to ours and post it to anyone, anywhere in the world. So on to tonight's main event, and our guest tonight is going to talk about vertical arrays for low band receiving. I must admit it's not something I've looked at before, but it's clearly something that's going to be interesting. Just to look at his QRZ page at an impressive array of antennas means that we're in for a real treat. So it's lovely to welcome Joel, W5ZN. Hello, Joel.
Hi, David. Good evening.
Good evening. Lovely to see you.
Yeah. The first thing I have to note is I was very pleased a few moments ago to note, and Tammy mentioned this, that you have thingamajiggers in the UK. We have those here in the United States as well. So I was pleased to hear that.
Yeah, we do, and we've been running this competition for ages. Just for your reference, Joel, because we started doing this online stuff at the beginning of COVID, and then initially we were doing who works from a shack like this, which was a picture of people's shack, and it was amazing, really, because we showed an insight into everybody's shack, and people had to guess who it was, and that was really good. But of course, there's only a finite number. However, since then we've been doing this "What on earth is this?" and there seems to be no real shortage of widgets and gadgets and gizmos. And what did you call it? Thingamajigs? Did you call it, or what was it?
Yeah.
Yeah. Okay, so yeah, it's been a very popular competition, and sometimes they're easy and sometimes they're not so much. But anyway,
I found that interesting.
good. Yeah. Did you know? By the way, did you know what the actual one, not the current one, but did you know what the previous one was?
No,
No,
I did not.
I had no idea either. So there was only 2 people that made it. Anyway, Joel, thank you for doing this talk tonight. As always, to everybody at home now, if you have a question or a comment to make for Joel, we'll be, of course, happy to read that to him at the end, and we'll get through as many questions and answers with Joel as we can. But now, over to Joel to learn more about vertical arrays for low band receiving.
All right. Thank you very much, David. And, you know, low band activity is something that I became, I've been a DXer for quite some time. There are a number of aspects of amateur radio that I love. DXing is one of them. And, as I started acquiring some good numbers in my DX pursuit over the years, I started migrating to some of the lower bands and to 40 meters, 80 meters, and into 160 meters. So I currently have 292 DX entities confirmed on 160 meters. And it's a pursuit that I've been after for some time. But one of the other passions I have is comparing receive antennas for the low bands. I have quite a good bit of land, which you'll see a photo of here later in some of the layout, where I can compare these antennas. So I put this together earlier this year after I collected a lot of data off of various receive arrays. So what we're going to cover today is we're going to talk just a little bit about low band propagation, my history with vertical arrays. And I want to talk about the differences in these arrays, because there are a number of vertical arrays that are arranged in a circle that have been used, and some of this can be confusing at times. Then talk about an approach to how you would compare these antennas, how I set up my test equipment and calibration, and the data collection and then the results. I have about 40 slides that I'll try to go through, but there is a lot more information contained in a paper that I have prepared, which is available on my website, that you can go if you're interested in looking at a little bit more about this. So first, about propagation. You know, geographical differences matter when comparing antennas. Now, if you're trying to compare antennas, you cannot do that by using a location, for example, where I'm located here in rural Arkansas in the United States, to someone who may be 1,000 miles away on the East Coast. You just won't get a valid comparison. And even if you compare the exact same antenna from two locations this far apart, you're going to have varying results. So by comparison, for 160-meter signals, I try to compare various signals on the air with stations that are around 450 miles. I'll use miles since I'm in the United States. I know that's not appropriate for you folks in the UK. But W0FLS, a good friend of mine, Dave, up in Iowa, north of me, around 425 miles. My other friend, Dave, W5UN, who's now a silent key, sadly, was about 200 miles southwest. Then another good friend of mine, Larry, K5RK, way down in South Texas, is about 450 miles to the southwest of me. And the propagation differences that we each experience, sort of comparing notes real time, is very interesting about what each of us can and cannot hear at any particular time. Even closer to my home, K5UR, WD5R, and K5EJ are both around 20 to 25 miles from me in different locations. And what we can hear, because as we compare notes frequently, is somewhat eye-opening, just that close. So propagation is really something that's beyond the scope of this presentation. However, I would encourage you to read some excellent work by Carl Lechelschwab, K9LA, and Frank Donovan, W3LPL, on this topic. They're both very well-known presenters. And Carl's info can be found on his website, which you see here on the screen. And Frank's data and presentations are posted everywhere. I refer to his presentations that they're almost like Santa Claus. They're everywhere. So if you just Google Frank or go to YouTube, you'll see a presentation by Frank. So my quest to really find the optimum receive antenna really started almost 25 years ago. I started out with using beverages and loop antennas, and these worked very well, but I always kept seeking improvement because I just felt like I never could take my receive capability to the next level. So in about 2008, Bob McGuire, N4HY, told me about a broadside in-fire vertical array that he had conducted an extensive amount of research and modeling and simulation on. So he was telling me about this, and I said, well, let's build one and let's see how it performs. So we did, and its performance exceeded what I was experiencing with beverages and loops. Not too long after that, Lee K7TJR came out with a high Z vertical array. Some of you may be familiar with high Z antennas here in the United States, out in Culver, Oregon. And Lee had this vertical array that some folks had started using and were really noting some very good results with it. So I thought, well, I need to try that. So I acquired one of those arrays. Excuse me. Then not too long after that, John Kaufman, W5ZN, who sadly is now a silent key, came up with a design with a 9 vertical array that was arranged in a circle. And this array was really picked up by the Yankee Clipper Contest Club, which is who John really did the work for. And it became affectionately known as the YCCC-9 array. So as I noted, there are differences in vertical arrays, and just because they're arranged in a circle doesn't mean they're all the same, and they're easily misunderstood. A few years ago at the Dayton Hamvention, I was at the top band dinner, and I had a radio amateur that was seated at the table with me, said he was putting up one of the 8 vertical arrays. So I told him, well, that's great. Which one? And he said, oh, the one with 9 verticals. So the math didn't really add up. So this requires a little explanation of these 3 arrays that I'm going to talk about here, and the differences that there are in them. So the first is the broadside end-fire array. Now, the broadside end-fire array uses 8 verticals that are arranged in a circle, as you see. But you're not using all 8 of these verticals at one time. You're only using 4 that are arranged here in a broadside and end-fire array for one particular direction. And these have really a really good pattern here that you can see from the simulation results. It's got a very good low angle, very sharp pattern, and produces some very, very good results. Now, the high Z antenna array is a little bit different. It does use 8 verticals, and these are short verticals. These short verticals are only about 20 to 25 feet in height. So they're not very tall. And a lot of people have used various material for the elements. I use aluminum tubing, small diameter aluminum tubing, but some people use wire elements. But if you look for the high Z, it contains 8 verticals, but all of them are phased together for any one direction. So you're switching the phasing and which ones are phased together for any one particular direction. So it's unlike the broadside end-fire array. It's using all 8. Its pattern is a little bit sharper than the broadside end-fire array, and performs very, very well. Now the W5ZN circle array again has 8 verticals that are arranged in a circle, all right? But it has an additional one that is in the middle. So for any one direction, you're only using 3 of these verticals, right? And the rest of them are not being used in a particular direction. I will note that for the broadside end-fire array, that's a very large circle. Those 8 verticals are arranged in a 350-foot diameter circle. So it takes a lot of large area. The high Z array is arranged in a 200-foot diameter circle. But here with the YCCC-9 array, it's only a 120-foot diameter circle. So it doesn't take up quite as much room. As you can see here, the Y5ZN array has a broader pattern in the azimuth as the other two, and it's simply because you're using 3 inline verticals. You don't have any kind of a broadside arrangement to sharpen up that pattern. So I need to talk a little bit about the beverage antenna as well. Now, I think most people are familiar with the beverage antenna that it's used for receiving. You know, it was introduced back in 1921, and it has rightfully become the standard by which we compare all low band antenna performance against. There's been a lot of books and papers published on the beverage antenna. So many you can hardly count them all. The original document that came out as sort of a go-to standard for the beverage antenna was the Beverage Antenna Handbook that was written by Vic Misick, W1WCR. It was first published back in about 1977. And it provided a lot of guidance for many years, but unfortunately, it's no longer in publication. Today, the go-to reference is really low-band DXing that John DeVolder, ON4UN, authored and published. And it's available today and has quite an extensive amount of information in it about beverage antennas. So Greg Orty, W8WWV, has written a number of papers about beverage antennas, and he coined the phrase the benchmark beverage. And he has a paper on his website here. And he comments in here that, for me, the beverage represents a yardstick which can be used to compare the performance of other receive antennas. So what I have done here in my tests and results, because I wholly agree with Greg's comment that the beverage antenna is the standard to use to compare other antennas to receive antennas. So to establish a performance base here in my results, I use a single wire 580-foot beverage that I have compared all of these vertical arrays to. So I'm fortunate that I live out in a rural area, and I have a lot of room. I have about 30 acres that I can lay out antennas. Now here on this area are basically my transmit antennas that if you go to my website, you'll see a photo of all of those. There are like 4 towers, and I have an 80-meter foursquare and so forth. So they're all contained here in this western section of my place. But the rest of the area that I have can be used for receive antennas, and I have quite a few laid out. The broadside end-fire array is located to the southeast of the shack. Then the high Z8 array is located due east of the shack. And these are about the high Z and the broadside end-fire array are about 800 feet away from the shack. Then the Y5ZN is over here slightly to just slightly north of west from the shack, about 500 feet away. And I have a variety of beverages that I have laid out as well. So that's the layout of sort of my antenna farm and my antenna range where I test antennas. So the parameters that I establish to conduct these tests is I want to compare modeling and simulation results. And that's very important to do to see how the performance of the antennas will work compared to how your modeling and simulation results are. I want to collect empirical data, real data off the air that we can use to compare with the simulation results. And then take both of those forms of data and determine if any modeling and simulation differences from the empirical data are present. And if there are, if you could really detect those in real world comparisons when you're using these antennas on day-to-day operation on 160 meters. So the test equipment that I used at the time to collect this data was it was comprised of 2 Elecraft K3 transceivers, 2 LP PAN software-defined IQ PAN adapters, and then I used the NAP3 PAN adapter display software. Now, I also have an antenna switch that I use where all of these antennas come into that I can switch between the various antennas. And this is a device that was designed and built by Gary Breed, K9AY. It's called an RAS-8 antenna switch, and it has 2 receiver outputs. So I can basically bring both the same antenna to 2 separate receivers or 2 separate antennas to each of the transceivers. Now, everyone should know that if you're going to start collecting data and running tests, you need to ensure that your equipment is calibrated. Now, that's very important. What I use to establish my calibration and verify that nothing has changed is a little signal source that is manufactured and sold by Elecraft. It's their XG3 signal source. The thing I really love about this is that it has a variety of different output levels. One of those levels is a minus 73 dBm signal, which is the equivalent of S9. So I like to use that signal injected into the far end of my system to really calibrate and make sure that nothing has changed with in my coax to the station, or something with one of the radios. So given that the distance of these arrays is approximately 800 feet from the shack, I'm using RG11 coax. These receive antennas I have are based and designed on a 75 ohm system. So rather than, since I have that long distance, I don't want to use RG59. So I use RG11, which is the RG8 equivalent 75 ohm coax. My measured loss on 1.8 megahertz is 2 dB through these long runs of cable. And I verify that daily prior to my tests. So if you recall, I noted on that RAS-8 antenna switch, I have 2 outputs. So anytime you split the outputs, you're going to have additional loss there. And there's 2.5 dB of loss once I split those 2 signals out. So if you take the minus 73 dBm signal injected at the far end of the cable, which is at the combiner output of each of the arrays, and you take this 4.5 dB loss, I should be seeing minus 77.5 dBm on the PAN adapter screen. And as I said, I verify this pretty much daily. So when I'm going to record data from each of these arrays, you need to include a variety of different measurements. Number one, you need to record the noise floor level. What's the level of the noise without any signals? Then I want to record forward peak. I want to record my front to back, and then my front to side measurements. So for these measurements, this is why I use a very good resolution PAN adapter display that's capable of a 1 dB resolution for measurement accuracy. You can't do this with an S meter. It's just not possible. So by using the PAN adapter display, I can look at signals and I said measure down to 1 dB accuracy if needed. All of the signals that I recorded, these signal levels, were recorded in CW mode with a 400 hertz bandwidth. And I did this during near dark time hours without noise blanking or noise reduction activated. So my signal measurement and comparison was conducted here actually over a 10-year period. This was not something that I did, just over like a year, because there are a lot of other variables over time that I wanted to try to capture. So the forward peak signal data that I recorded was from over 100 DX stations that were outside the United States. Now, a few of these were the same station, but I acquired the data during either a different time of day, a different time of year, or a different time during the solar cycle. Now, since all of the DX signals are really too weak for me to document signal amplitude and antenna directions other than the direct path, in other words, my ability to measure front to side or front to back ratio, I had to utilize data from approximately 30 stations in the United States to collect this data for pattern comparison to the model. And I did this with the understanding that the USA stations will prevent a variety of different signal arrival angles that would be originating from different transmit antenna configurations. But regardless, the results that I have recorded are accurate. So, as I noted, one of the things we need to measure is the noise floor. And comparing the measurement of each array's noise floor must take into consideration whether it's an active or a passive system. And what I mean by an active or a passive system is whether or not there is any amplification at the array. Now, the high Z array and the Y/CCC array, because they're high impedance arrays, they do have amplifiers that are included in the system. The broadside end-fire array does not. It's a straight 75 ohm system, so it's a passive array. It doesn't have any preamplifiers or amplifiers out at the array side. So I recorded the noise floor from each of the arrays and documented it in each of the 8 directions in 45-degree steps. Now, that's important because if you have a noise source in one direction that you may not have in another, you need to be aware of that and record it. So for the 2 8 vertical arrays with no external preamp, the noise floor in the shack through the 800 feet of feed line in the antenna switch averages around minus 120 dBm. That's pretty good. I used to get a better noise floor than that about 10 years ago. But over the 10 years, I've seen a lot of consumer devices become active in my area and create a lot of new noise. So my noise floor has been increasing over the years. The output of the Y/CCC9 is low, and I do have a preamp on the output of the phasing unit, and that's recommended in the Y/CCC documentation. Its noise floor is lower, which is to be expected. It's minus 125 dBm. And that's 5 dB less than the 2 8 vertical arrays, but it's very active for comparative measurements. Just by comparison with the beverages, the 4 beverage antennas that I have a noise floor of minus 125 dB. Now, I will note that, I've spent many days and weeks working with my electric utility to really eliminate line noise. And at least for now, my location is as quiet as possible and consistent in all directions. Now, we're coming into the fall, and I'll have all of my receive antennas deployed and active here in probably another 2 or 3 weeks. So it's going, because I don't have them really active in the summertime here because of lightning and so forth, and a lot of the expensive electronics that are associated with them. I take those up during the summertime. So when I deploy those here in about another couple of weeks, we'll see if I have any new noise sources in any particular direction. Now, that's line noise, but what's out of my control are noise sources from consumer products in my neighbors' houses. Even though I'm sitting here on a 30-acre plot, across the road to my north, I have houses. Way down about a quarter of a mile down on the highway, there are houses across the highway there. And some of these noise sources can travel those distances, but they can be annoying at times. But I don't have any issues at the moment. So when I record the forward peak signal amplitude, that's simply the strength of the received signal in the forward or the direct path to the originating station. Now, there were a couple of times where there's an exception to this when I recorded data, and that was when a station presented a maximum signal from a skewed path or a longer path along the gray line rather than direct path. And I recorded my levels in dBm and their reference to the noise floor. So if I record a peak signal at minus 120 dBm with a minus 120 dBm noise floor, that signal was recorded as being 5 dB above the noise floor. Just to give you an idea of some of the DX stations that I recorded data from, there's quite a good number here, and they're located at various places all over the world. So to give you some results, the forward peak results from the high Z-8 array provided a 1 to 2 dB increase over the broadside end-fire array on some signals. And then there were other times when the broadside end-fire array would outperform the high Z by the same difference. And there were some times when I could even be monitoring the same station over a period of time, and this result would reverse itself. So there's no consistent difference between the two arrays in the forward peak signal. Now, the Y/CCC9 array was consistently 2 to 3 dB lower than the two 8 vertical arrays. So the forward peak signal on the beverages was consistently 3 dB lower than the broadside end-fire and high Z array, but it was equivalent to or maybe around 1 dB, which would be somewhat difficult to really detect, lower than the Y/CCC9. Now, there were some times when the vertical arrays and all of the 3 vertical arrays recovered from deep fades before the beverage did. And, I thought about this for a while, and this was not due to the increased gain or signal level of the vertical arrays over the beverage, because, at times the vertical array signal would reappear out of the noise at a high enough amplitude that the beverage just should have revealed the signal. So I can't really explain that. It's something I have documented, and maybe something will be looked at and revealed over time. So here's just a simple line graph of some of the results in forward peak amplitude of the various results. You'll see the top 2 highest amplitude lines is the high Z array and the broadside end-fire array. Then you'll see the 2 lines that are just lower than those is the Y/CCC and the beverage, and they're comparable as well. So what about front to back and front to side comparisons? The high Z array exhibited a really, really nice 25 to 30 dB front to back repeatedly when we were comparing multiple signals. The broadside end-fire array was a little bit less, about 20 to 25 dB. But remember, the high Z array is using all 8 verticals phased together in 3 different phasing schemes to achieve a pretty significant front to back ratio. Now, the Y-C-C-9 is really exceptional and in line with the high Z8 at 25 to 30 dB. But if you recall, that uses 3 inline verticals. So that should afford a significant front to back ratio, and this was expected. Now, on my beverages, I averaged around 20 dB front to back and front to side, and that was equivalent to the Y-C-C-9. So what about modeling versus the actual field measurements? Now, if you have any experience or have studied receive antennas, you'll note that receiving directivity factor, RDF, has really become the standard to compare modeling data for receive antennas. Some of the early work in this area defining RDF was conducted by Bill Hohenstein, K0HA. And basically what RDF does is it takes the signals from all around the entire antenna's pattern and gives a good representation of its noise rejection, or how it responds to noise over the entire pattern, and not just the forward lobe. So that's something to, I won't go into that because this is, beyond the topic here, but if you want to read about RDF, you can Google it online or look at a lot of information in low band DX. So when you start comparing, though, some of this data, especially if you're going to equate front to back or front to side to modeling data, that can be difficult in a simple test environment because there are multiple factors that come into play. Because if you look at the back of a modeling result, a simulation result, you usually have a null off the bat. And if what comes into play is the arrival angle of the desired signal, the arrival angle of any undesired signals, characteristics of noise generated conditions, and construction of the array components in relation to the design. So what I did was I took all of the documented data that I had and I compared it to some 3-dimensional designs in 4NEC2. I really, when I looked at these, I really came up with some comparisons, and I actually did some RDF comparison, and I did that based on comparative signal analysis from 8 directions. And if you recall, RDF takes into account the entire pattern of an antenna to come up with the results. So I tried to collect data from 8 azimuth directions and apply that and use a comparative analysis. So if you look in the upper left-hand corner, this is a 600-foot beverage that is comparable to my 580-foot beverage. And it suggests from this modeling, the simulation result, an 11.1 RDF. I actually determined that it was around 10 dB, so that's real close. And my front to back of 20 dB with a 3 dB beam width of 75 degrees is comparable. But if you go down to, let's go over to the Y-C-C-9. It has a simulation product of 12 dB RDF. And I determined that was pretty accurate. Also, you have a front to back of 20 dB. I came up with a little bit better than that. 3 dB beam width of 75 degrees. Now, the high Z8, if you'll notice, it is a much sharper, much cleaner pattern. And the results that I came up with are very, very close to that. Now, I saved the broadside end-fire array until last. I concluded the RDF was about 12.5 dB, which is right in line with the simulation results. Well, one thing that concerned me was this hump off the back here. Okay. I thought that's not right. Something just really is not right with this. And I started trying to investigate why, because I really expected something cleaner along lines with the YCCC or the high Z. And what I did was I went back and I looked at the elevation pattern. And I noticed that on the elevation pattern, which I have shown here, there is a pretty high lobe. It's only about 15 dB below the main lobe that is extended out here at about, I don't know, 50 degrees or so. And then you go through another null, then you have another lobe close to the ground. So what I concluded was what we're seeing here from a 3D pattern is just the assimilation of those two lobes. And it's producing not as clean as a pattern off the back as the other two. So what about using these arrays during contests? Again, this was DXing. Now, I did not collect data of really any detail during contest activity, although they were somewhat evaluated during the major DX contest. I mean, in a contest, my objective is to acquire as many cues and multipliers as I can and not sit there and try to record data. But each array produced really outstanding results and significant reductions in signals off the back. I noted Frank Donovan off the start. Frank is near the east coast of the United States, and he has one of these broadside end-fire arrays. And they're really good. They're really good patterns and a lot of rear rejection. But I'll tell you, if you're using one of these arrays during a contest and you're listening to Europe or the UK, you know, close to your sunrise there, and we still have darkness in the Caribbean or South America. If you get called by a Caribbean or South American station and you're listening toward Europe or the UK, you're not going to hear the South American station calling. So in a contest environment, you need to be aware of that. So just in summary, phased receiving arrays of short verticals provides superior performance over other low noise receiving antennas, including beverages and loops. The low band receiving antenna that's going to be appropriate for your location or any specific location is going to depend on a number of factors. Most importantly, the available area for the installation. So the high Z-8 array for 160 meters in a 200-foot diameter circle, my data confirms the modeling data, and it has consistently been the top performing array here at my station. The design produces the best overall pattern, and it's very sharp and clear. On the broadside end-fire array, configured for 160 meters, and again, it's a 350-foot diameter circle. It's large. It's very close to the high Z-8. The forward signal levels are equivalent, but as I noted, the rear lobes do not provide an equivalent front to back or front to side as the high Z-8 does. Regardless, this array is a top performer, and I ranked it second in my evaluation. Now, the YCCC9 in its 120-foot diameter circle provides some really amazing results in forward signal level and front to back. The deeper nulls that it has on front to back are equivalent to the high Z-8. Now, it does not provide or produce results in forward signal and front to side as the other two arrays. But for the amount of space that's required, you can't dismiss this array. It's really a top performer. And here's something else about it. In this spacing configuration, and with the correct delay lines described in the construction details that are available on the web, you can use this array on both 80 and 40 meters as well as 160 meters with outstanding performance. And here's a really key point about this that I like to mention. If you only need 3 elements for any one direction, so for example, here in the United States, if I wanted to focus on Europe or the UK, and I had 120 feet available in my northeast direction, then I could put up 3 of these elements, and it would give me the same performance or better as a 500-foot beverage with 20% of the required space. And I stress this all the time, that this is an easy array to construct. And if you're limited for space, you can get the same performance as a beverage. And this array can be used, as I said, on 3 bands. So just some final thoughts. The array that's best suited for your location must be assessed. And the criteria includes not only the area required, but the benefits and challenges that exist with each. And in my paper that's on the website, I note some of the pros and cons of each one of these. Now, I will tell you on 160 meters, I noted that the high Z-8 is the receive antenna that I use. That's my primary go-to antenna on 160 meters. But I'll tell you, when conditions are marginal and extreme, and that there's a DX station that I need to work, I use the high Z-8 together with the broadside Infire array in a diversity receive configuration with an Elecraft K4D. I previously did this with the Elecraft K3. But this performance is nothing short of amazing. And it brings a signal that's just at the noise up to a very copyable level. So the test that I describe here and that I've performed, it's simple, but yet it's accurate. And there's been a lot of technological advances in software and hardware components in recent years that's currently being evaluated and used, not just by industry professionals, but some radio amateurs. And some of those new technologies, those new capabilities to measure and record signals could be used to build on this work here. And it's my desire that this work can aid some future confirmatory research and possibly serve as a baseline for applying empirical data to modeled results. So again, thank you very much for the opportunity to be here today. And again, visit my website if you'd like to download this paper that has some more information in it. And with that, David, thank you very much. And if anyone has questions, I'm more than happy to address those.
Thanks very much, Joel. A very comprehensive look at what is actually quite a complex subject, at least I think it is. But as you said, I mean, I think I can't summarize, obviously, all of your nearly an hour presentation with a few things, but it was interesting at the end. One highlight I'll take away from it is that, with 3 elements, with just 3 elements like that, you can get the performance in just 20% of the space. And I think you said that you had maybe 30 acres or so. Well, I think that I speak for most people certainly watching this, and most club members, that most people don't have that sort of space. So that does give everybody hope, I think.
Yeah, yes, it does. And I like to emphasize that because I know I have a lot of friends who are space limited. And they really try to figure out what they can do to improve their receive capabilities on the low bands. And my first go-to recommendation is to use, if you have 120 feet in a particular direction, install 3 of these elements from the YCCC array and you have 580-foot beverage performance, and it works very well. So I would encourage everyone to try that. If you're interested in low band receiving and you want to improve your reception capabilities, you have a little bit of space, give one of those a try.
Yeah, 120 feet is much more doable probably for many of the people watching this. So if you're watching this at home and you have any questions or comments or observations or maybe shared experiences that you want to share now with Joel, this is the time to get them down either on BATC or Facebook, and I'll read them to Joel immediately. When you were doing all of this comparative tests and research, I assume that both the stations were the same you had. If people want to do similar work, do they have to use the same receiver, do you think? Because you mentioned that calibration was very important. So if you don't have two exactly the same transceivers, is that okay?
Yeah, that would be okay. The receiver was not specifically, what you need to be able to do is display the signals on a pan adapter. And a pan adapter that has sufficient resolution that you could measure small changes in signal levels. The Elecraft K3s were not as important, although that's a very good radio. But those two radios, if I could have output the received signal data on a pan adapter with the resolution I was able to acquire using the Elecraft, then that would work just as fine.
So, I mean, looking at a modern radio like the 7300, which has got a kind of that sort of pan adapter type display with waterfall, is that going to give you enough resolution, a small screen like that?
The pan adapter on the 7300 by itself does not have sufficient resolution. But I believe there are pan adapter programs that are available for the 7300 that you can use and acquire better resolution than you can on the pan adapter that's included with the 7300. But the 7300, its drawback is only the pan adapter that you have in the receiver. Nothing wrong with the radio whatsoever.
No, and it might be that I know they've just announced the Mark II. We just had a Hamfest, as you probably saw on our news earlier on. And they were showing the new Mark II there, and one of the things that it has got, apart from an output to a larger screen, which may or may not mean, of course, there's more resolution, but as they've got an HDMI socket on it, maybe it does mean there's a higher resolution that you'll actually see on the screen. But also, you've got a separate receiver input and output, I believe. You've got access to that. So that might also enable that with something, a little bit more affordable, shall we say, than some of the very high-end transceivers. I always ask experts in antennas, and I'm going to include you in that. You may be too modest to say that you are, but you clearly have done a lot of research. This is not something you just do lightly. Do you think there are other types of antennas that are yet to be invented or yet to be discovered, shall we say? Because although we've seen incredible improvements into the technology used in the transceivers and the receivers, the transmitters and the computers used with them, and even AI nowadays as well, we haven't really, I don't think, seen that many changes in the basic building blocks of antennas. Is there something that you have a feeling that might be around the corner that would change everybody's mind?
I believe so. I don't know what those are, but if you take a look at some of the improvements in our technology, for example, going from analog to digital technology, and I believe that there are possibilities down the road that will be applied to antennas. I can tell you right now that there are two different types of arrays that I've been asked to test here for low band receiving. They're all designed around short vertical arrays, but they're different arrangements, different configurations. But if you look at a lot of the, I see a lot of of designs in antennas. And I see some that look like they could have promise, and some that I just look at and I'm like, well, I don't think those will ever work. And it turns out I get proven wrong about something because I don't consider myself an expert or an engineer in that area. But I wouldn't be surprised, David, to see 10 years down the road. Think back 10 years and what we've seen as changes and improvements in some of our hardware and software. And I just believe that as those continue to improve, it's going to evolve over into some of our antenna hardware, and we're going to be able to come up with a lot of different designs that are going to be significant improvements. I have no idea what those are, but I believe it's coming.
Good, and I agree with you as well. I'm a little bit of a scientist inside, I think, and unless you can prove otherwise, then there's nothing to say that everything has been invented. We haven't got any other questions for you. I just repeat your website, if I may, because that paper, the full details are there. It's www.w5zn.org, and you can access that and lots of other information about what you've talked about tonight. Joel, it's been a delight to have you with us. Thank you so much for this presentation.
Good. Thank you for the invitation, David. I've enjoyed it, and thank you very much.
A pleasure.
I hope it was informative to everyone.
I'm certain it was, and good luck with your research and things, and do come back and tell us if you discover one of those new antennas or some fantastic new thing that we can fit a wonderful antenna in a rather smaller garden. So thank you very much indeed for tonight.
Will do. Thank you, David.
Thanks, Joel. There we are. Thanks very much indeed to Joel, W5ZN. And again, his website, one more time, is w5zn.org. And you can download that paper and everything else that refers to things that Joel has been talking about this evening. So thank you very much to him. Thank you very much for you for watching. Just to tell you again what's happening at the club this week. So this time next week, we're meeting at the CNS School for an informal and also our popular show and share table, which I said don't underestimate that. If you haven't been yet, it's really good to see. On Sunday, we've got the GB2RS news as well on GB3MB. Don't forget to keep in touch with your news and your stories and your pictures and everything. And if you've got any interesting items for What on Earth, we'd love to see those as well. But for now, from Tammy M0TC.
Bye-bye.
And from me, David G7URP. Take care of yourselves. Look after each other. Bye-bye.